Good morning, everyone. So, next topic after valence bond theory, that is isomerism. So, this isomerism, why the compounds exhibit isomerism? So, because the compounds exhibit isomerism due to their nature of bond. So, we have different types of compounds: ionic compounds, covalent compounds, coordinate covalent compounds. Out of these out of these three, except ionic compounds, covalent compounds, whereas coordinate covalent compounds can exhibit isomerism. Why? Because the bond which is combines are present in such compounds is a directional bond. So that means that bond has a direction, whereas non-ionic compounds, the ionic bond is non-directional bond, so it doesn't have any direction. But whereas a covalent bond as well as coordinate covalent bond is a directional bond. So that's why the compounds which are having these bonds, such compounds can exhibit isomerism. So according to valency bond theory, the bond present between metal and ligand is coordinate covalent bond. Since coordinate covalent bond is a directional bond, so that's why obviously this can exhibit isomerism. Okay, let's see what is isomerism. So isomerism means having same molecular formula but exhibit different physical chemical properties. So here see, I will show you with spotter. Okay, so look at this, same atoms. So that means that molecule have same molecular formula. That means it may have same atoms. So if S, then we can say isomers. If no, those are not isomers. So those are different isomers. Those are not isomers. If the any compound which has similar molecular formula or same atoms and exhibit different properties, such compounds are known as isomers. Next, on the basis of linkage, if generally atoms of a compound are bonded through a link means that is a bond. So if the linkage is same, so then we can say stereoisomers. If bond linkage is different, then we can say structural isomers. So though it has same molecular formula, but the structural isomers are the isomers which are having same molecular formula, but they are connected to different atoms. Our connectivity, or we can say linkage, or we can say bonds are different. So on the basis of this, these are again four types. Structural isomers are further classified into four types. So today we will discuss about this topic, and it is very important. You can expect in examination as a short question. So structural isomers. What are structural isomers? The isomers means having more than one compound. So more than one compound having same molecular formula, but those are connected are having different linkages or bondages, and due to that difference in bondage or different in linkage, they exhibit different physical chemical properties. So such compounds are known as structural isomers, and these structural isomers are four types. First one is ionization isomers, second one is hydrated isomers, third one is linkage isomers, and fourth one is coordination isomers. Okay, so we have more than four, but in your syllabus you have only four. Okay, so let's see one by one. So see, so in organic chemistry, just recall the organic chemistry. In organic chemistry, the structural isomers generally we classified as chain isomers, position isomers. Here see, so this is position isomer, and this is molecular isomer, functional isomer. See, here this is propanol. This is propanol, and this OH group is substituted to first carbon. So that's why it is a one propanol. Now this see in second compound, this is two propanol. Here, what is the difference? Having same molecular formula. Both are having same C3H8O, same molecular formula, but differs in bond linkages. Here this OH group is connected to first carbon in one propanol, but here that OH group is connected to second carbon. So bond connectivity or linkage is different. So that's why these are structural isomers. And see here we have one more isomer, that is functional isomer. We can say these are functional isomers. Why? Because see, connectivity is different. Here see again, if you look at this OH bond of hydrogen, here this oxygen is connected to one side, that is connected to carbon, and another side it is connected to the oxygen in this compound. But whereas here, this both sides, this oxygen is connected to the carbon atoms. So that's why here again, these two molecules are having same molecular formula, but a difference in bond connectivity. So that's why these are known as structural isomers. So what are structural isomers? Having same molecular formula, but a difference in bond connectivity. So due to difference in bond connectivity, they exhibit different physical chemical properties. So already this one is we have studied in our previous in the last year. Okay. So now come to structural isomers of, or we can say constitutional isomers of coordination compounds. So see here, see, structural or coordination isomers are the molecule with same kind and number of atoms. So that means we can say molecular form, but with a different bond arrangement. Bond arrangement means linkage, different linkages. Here this group is linked to first carbon, here this group is linked to second carbon. So that linkage is different, or bond connectivity. In coordination complex, there are four types of structural isomers. So first one are hydrated isomers. First, see, look at this example, chromium hexa aqua chloride. So this is, the color of this crystal is violet. Okay, see. So here the ligands are water. Ligands are water, and this is counter ion. Cl minus is the counter ion, whereas this water acts as a neutral monodentate ligand. So if one of this water molecule is exchanged with chloride, so then look at second example. Here see the what is the difference? So only bond connectivity is different, but whereas molecular formula is same. Here also we have one chromium, and here we have 6 water molecules. Here also we have 6 water molecules. Here we have 3 chlorides. Here also we have 3 chlorides. Both are having same molecular formula, but it differs in arrangement. Here the ligands are water acts as a ligand here, but how many 6 water molecules are present in complex? Okay, are square, or we can say ligands. But in this case, here what happened? One of the water molecule is exchanged with chloride. So now how many water molecules are present in sphere? 5. But whereas here 6. And here the chlorides, 3 chloride ions are acted as a counter ions. So those are present out of sphere. But here 1 chloride is present inside the sphere. So due to difference in arrangement, just now I told you stereoisomers, isomers having same molecular formula but exhibit different physical chemical properties. So I will show you one physical property. The color of this complex is violet, but whereas due to difference in connectivity, the color of this crystal is changed from violet to blue green. If you change, or if you exchange one more water molecule, then you will get this. And look at this color of these two. Here this is appears as blue green, but here as dark green. If you further exchange one more water molecule, you may get this one, and the color is yellow green crystal. So that means when we change the bond linkage, that accompanies change in physical as well as chemical properties. So that's why these four are known as hydrated structural isomers. Why? Why? Because hydrate means water molecule. So water molecule here is exchanged. Okay. Next, second one is ionization isomers. So same thing, exchange of ligands, ligand with ion. So here in hydrated isomers, what we have done, we exchanged water molecule with an anion. But whereas in ionization isomers, we exchange a ligand with an anion, the negatively charged ligand. So, or you can say except water, if you exchange other monodentate, negatively charged monodentate ligands with anion. So here see CONH3 is SO4N3. So here this NO3 is present in outside of the complex, and whereas NH3 present in the complex. Okay, and SO4 also present in the complex. Now what we have done, we exchanged these two, sulfate with NO3. So then we got this one, then we got this one, and due to this what happens? The physical properties also change. So ionization isomers afford different anions and cations in solution. So here what happened, different anions are exchanged, or we can say cations will be exchanged. So that results the formation of new isomer, and such isomers are known as ionization isomers. And next, third one is coordination isomers. So coordination isomers. Okay, so it is somewhat so these two, the coordination. So in this coordination isomers, we have two parts, two complex pairs. This one complex pair, this complex acts as a cation, and this complex acts as a anion. Okay, and so now here see what are coordination isomers. Here see in first sphere we have three ammonia and one chlorine, and second sphere we have three chlorides and one ammonia. So this is one compound. This is one compound. This is second compound, and this second compound is formed due to exchange of this chlorine with this ammonia. Okay, so that that provides that produces a platinum NH4 and platinum Cl4 complex. These two different spheres of one complex, one coordination compound, and these are two different spheres of one coordination compound, and these two having same molecular form. But here what happens, the connectivity is different. So here in this first sphere, this platinum is connected to three ammonia and one chloride, but whereas in the first sphere of second compound, this one platinum is connected to four ammonia molecules. So here this is reverse. So this platinum is connected to three chlorides and one ammonia, and in this compound this platinum is connected to four chloride ions. So this type of isomers are known as coordination isomers. And next one is, another one is linkage isomers. So when we can expect linkage isomers, when we have ambident ligands. When we have ambident ligand, so then that ligand can produce this linkage isomers. What is ambident ligand? Ambident ligand is a monodentate ligand which has more than one donor center. If any monodentate ligand which has more than one donor center, then such ligands are known as ambident ligand. Okay. Look at see. So here in this example, so this is cobalt NH3NO2. The formula of these two compounds is CONH3 taken 5 and NO2. But here see this, here in this sphere, this cobalt is linked to oxygen of NO2 group. In this compound, this cobalt, so that is central metal ion, is linked to the oxygen of nitro group. But here see, in this compound, the same central metal ion, that is cobalt, that is linked to nitrogen of NO2 group. Here oxygen of NO2 and here nitrogen of NO2. So that means this NO2 having two donor atoms. What is that? One is oxygen, second one is nitrogen. So in first case, this is connected to the oxygen, and second case that is connected to the nitrogen. So that's why these two are known as linkage isomers. The bond linkage or bond connectivity is different. So that's why this is known as stereoisomer. So this is about structural, or you can say constitutional isomers. So constitutional isomers are four types. What are those? Hydrated isomers, ionization isomers, coordination isomers, linkage isomers. Okay. So next class we will discuss about stereoisomers. Okay. So stereoisomers. Okay. So if you please go back to the first slide, you can see if the molecular formula is same and bond connectivity also same, then such isomers are known as stereoisomers. And these stereoisomers again classified on the basis of mirror image. If those are mirror images, then we can say geometric isomers, and if stereoisomers are not mirror images, then we can say optical isomers. And already in previous class, in last year, you have studied about studied that geometrical isomers are two types on the basis of orientation of groups. If similar groups present on same side, then that conformation is known as cis. If similar groups are opposite side, see here, see, similar groups here, green bond, here red ball and red ball, both are present on same side. That's why this is known as cis. And here this red ball and this red ball, those are arranged or oriented opposite to each other. So this configuration, or you can say conformation, as trans. So again, geometrical isomers are two types, cis and trans. If similar groups oriented on same side, then that conformation is known as cis. If similar groups are arranged or oriented opposite to each other, then that conformation is known as trans. When it produces mirror image. If our stereoisomer doesn't produce mirror images, then we can say optical isomers. And so here see, this is tetrahedral molecule, and these are two non-superimposable, sorry, what we say, non-mirror images. Okay. And next see, and again optical isomers are two types. One is enantiomer, second one is diastereomers. Enantiomer means, so to exhibit optical isomerism, this that molecule should have a chiral center or at least chiral plane or chiral axis. But in your syllabus you have only chiral center. You restricted up to chiral center. Maybe in next year we will study about the optical isomers which is having chiral plane as well as chiral axis. Okay, so you can find such in organic compounds frequently, but in coordination compounds you have only enantiomers and diastereomers which are due to presence of chiral center. What is chiral center? The center are the atom which is connected to four different groups or species. Then we can say chiral. Okay. Next, you see enantiomers. Enantiomers are what? Those are mirror images and non-superimposable. And diastereomers are non-mirror images and non-superimposable. Okay. So here complexes identical to its mirror images. If S identical means superimposable. If mirror images are superimposable, then we can say geometrical isomers. If mirror images are not superimposable, then we can say optical isomers. Those may be mirror images or may not be mirror images, whatever it may be, but the complex identical to its mirror images. No means optical. If complex identical to its mirror images, geometrical isomers. Okay, so we will discuss about stereoisomers in next class. Okay, so up to now we have discussed about structural isomers, or you can say constitutional isomers. These are four types: ionization, hydrated, linkage, and coordination. So hydrated isomers are only exchange of water molecule with counter ion. So that is known as hydrated. In ionization, exchange of any anion with counter ion or cation with counter ion is known as isomer. Linkages means when the central metal ion will connect it to a ambident ligand. So in that case, we can expect two different linkages. So linkage. Coordination isomers means in this case we have a complex with a complex compound with two spheres. So those two spheres will have different arrangement. Okay. So this is about stereoisomers. In next class, we will discuss about, sorry, this is up to now what we have discussed. We have discussed about structural isomers, or you can say constitutional isomers. And next class, we will discuss about stereoisomers. Okay, thank you.